All right, let's dive in. Today, we're decoding the Cambridge Computer Science course. We're going to pull back the curtain and really find out what it's like to study computer science at this level.
So you're curious about computer science, but have you ever stopped to wonder, beyond all the buzzwords and the hype, what do you actually learn? Is it just endless hours of staring at a screen and coding, or is there something more to it? That's exactly what we're going to break down.
You see, the official name for the course guide is the Scheme of Work. Yeah, I know it sounds a little dry, doesn't it? But trust me, it's so much better to think of it as a roadmap. It's this incredible journey that takes you from the absolute basics of how a computer thinks all the way to being able to command it to do amazing things.
And when you look at how the course's 130 hours are divvied up, something really interesting jumps out. Programming is actually less than a quarter of the whole thing. A huge chunk is dedicated to hardware, algorithms, and other fundamentals. And that tells you everything you need to know. This isn't just a how-to-code class. It's about building a deep, well-rounded understanding of the entire digital world.
Really, the best way to get your head around this roadmap is to see it as a story told in two distinct parts. Part 1 is all about understanding the machine, and Part 2, that's about commanding the machine. So let's start at the beginning with Part 1.
So this first half, it's all about the foundations, the theory. You can think of it like this. You're learning the laws of physics for the digital universe before you try to build a spaceship. You have to know the rules before you can get creative.
And where does that begin? Well, it starts with the computer's native language. And no, it's not English, it's not Python, it's binary. It all boils down to just two numbers, ones and zeros. Before you can do anything else, you have to learn this fundamental alphabet.
Now this is where it gets really mind-blowing. The course shows you how these simple little on and off signals, the ones and zeros, are cleverly arranged to represent, well, everything. Literally, every photo on your phone, every song you stream, every message you send. Deep down, it's all just ones and zeros in a very specific order.
Of course, it's not enough just to have the data. You need to be able to send it, right? So you'll dig into how that information gets bundled up, shot across the internet, and this is the crucial part, how things like encryption work to keep it all safe and secure from prying eyes.
From there, we pop the hood and look inside the engine. You'll learn about something called the von Neumann architecture. It's basically the master blueprint that almost every single computer today is built on. It's what explains how the CPU, the brain of the computer, grabs instructions, figures out what they mean, and then actually does them.
And all that hardware understanding naturally leads us to the next layer up, software. You'll learn that not all programming languages are created equal. You've got high-level languages that are closer to how humans talk, making them easier to write, and then you've got low-level languages that are almost speaking directly to the metal, giving you insane control. Both are powerful in their own ways.
And just so we're clear, this isn't some dusty, old-school theory class, no way. The course brings you right up to the cutting edge, looking at the huge topics that are shaping our world right now. We're talking cybersecurity threats like malware and phishing, all the way to the incredible future of AI and robotics. Okay, deep breath. That's part 1. You've learned the machine's language, you understand its anatomy. So what's next? Well, now you get to be the boss. In the second half, you learn how to make the machine do exactly what you want it to. This is where all that theory gets put into practice.
And everything in this practical world starts with something called an algorithm. Now, it sounds like a fancy, complicated word, but it's not. Honestly, just think of it as a recipe. It's a super clear, step-by-step set of instructions that you give to a computer to solve a problem. Getting good at writing these recipes is the real secret to solving problems with code.
And you don't just dive in and start typing. See, what separates a hobbyist from a professional is having a process. This course teaches you that professional workflow. You learn to analyze the problem first, then design your solution, then you write the code, and finally, you test the heck out of it to make sure it actually works. It's a discipline, and it's essential.
So much of our world runs on data. I mean, massive amounts of it. So you're going to get hands-on with SQL. It's the universal language for talking to databases. It's an incredibly practical skill that lets you organize and pull out exactly the information you need from gigantic collections of data. Super valuable.
So we have these two big halves, right? Part 1 is the theory, part 2 is the practice. But here's the most important part. They're not separate things. The real magic, that aha moment, happens when you see exactly how they plug into each other. Let me show you a perfect example. In the theory part of the course, you'll learn about something that seems really abstract, like super disconnected from the real world. It's called Boolean logic. At first, you might be thinking, okay, this is math. When am I ever going to use this?
You'll see a truth table like this one for an AND gate. The logic is simple. If input A is true and input B is true, then the output is true. In every other case, it's false. Okay, makes sense, but still feels pretty abstract, right? So the big question is, how does something like that, a little table of trues and falses, actually become part of a useful program that you and I use every single day? Boom, here's how. That simple AND logic is the engine behind pretty much every single login screen on the internet. The code is literally checking. If the username is valid and the password is correct, then let the person in. That's it. That abstract idea from part 1 just became a powerful, practical tool in part 2. That's the connection.
So let's just zoom out for a second. We've seen the what, but let's talk about the why. Why does a course structured like this even matter? Because it's designed to teach you something so much bigger, so much more important than just how to write code.
And this right here, this is the ultimate goal. The whole point of this entire journey is to build a new way of thinking called computational thinking. It's about learning how to take huge, messy, complicated problems and break them down into smaller, logical, manageable pieces. And let me tell you, that is a superpower you can apply to absolutely anything in life.
So at the end of this journey, you don't just walk away with skills, you walk away with a powerful new lens for looking at the world and a toolkit for actually building solutions, which leaves us with just one final, really exciting question. What problems are you going to solve?